Alright guys, so today we're going to be talking about actually solving quadratic equations. So we have been working with quadratics for a while now. We've done vertex, standard form, vertex form, finding the axes of symmetry, graphing them. So now we're going to actually start getting into solving them, okay? So as I'm going through and filling out these notes, you guys should be doing the same thing. Okay, so make sure you're filling this in as you're listening. All right, so the solutions to a quadratic equation are the points at which the function intersects the x-axis. So you will notice that when we solve quadratic equations, they're going to equal 0, all right? Because anytime you cross the x-axis, your y value is going to be 0. Okay, so wherever the parabola crosses the x-axis, those are your solutions. Now, we have a thing called the fundamental theorem of algebra. And what that theorem tells us is that whatever your highest exponent is in your equation, that is how many solutions you have. So with quadratics, our highest exponent is 2, so you should have 2 solutions. If I had x to the third plus 3x minus 6, I would know that I would have 3 solutions because it's to the third power. All right, so with quadratics, we're going to have 2 solutions. All right, there is something down here where it says 1 solution, and we'll talk about that, but that's called a double root, meaning it's the same answer twice. So really, technically, there's still 2 solutions. Excuse me. All right, the solutions are also referred to as, we call them zeros, we can call them roots, or we can call them x-intercepts. Okay, most commonly you're going to hear them referred to as zeros or roots. Okay, those are just synonyms. These 3 are just synonyms for solution, right? So when we talk about a quadratic equation, when I say find all the zeros, that means you're finding all the solutions, which means you're finding where the graph crosses the x-axis. Okay, also roots, say what are the 2 roots? Again, where it crosses the x-axis. All right, so when we're thinking about graphs, we've already done graphing, so let's go back to graphs. So a 2-solution parabola would look something like this, right? Where it crosses through and you have 1 and you have 2 solutions. So it crosses the x-axis twice. For 1 solution, it would be something like this, where it just touches the x-axis, doesn't actually go through it. Okay, so then we only have 1 solution. And then no real solutions would be something like this, where the parabola actually doesn't ever cross the x-axis, okay? We'll get to that after Christmas. This is going to be where you have complex solutions, and we'll talk about that later. But from the graph, you can see that you are not crossing the x-axis, therefore no real solutions, okay? All right, so we're just going to briefly go through these, all right? So on this, we have... This is, we're going to graph this. I'm just going to make a quick table. You can also do this on your calculator. Put that into your calculator, go to your table, find your vertex. So our vertex on this one is -1, -4. We're just going to do a couple of these. So let's see, 0, -3, -3, 0. So here are my points. I'm just going to plot these. So -3, 1, 1, 2, 3, 0. -2, 2, 3. -1, -4. Like this. So here's our parabola. So then we're looking... And there's the graph of it, so now we need to find the solutions, and the solutions are going to be where it crosses the x-axis. So here it crosses at -1, 2, 3. So one of my solutions is at x equals -3, and my other one crosses at x equals 1. Okay, so those are my 2 roots. We can call them our 2 zeros, our 2 x-intercepts, our 2 solutions. Okay, so this one is like this first one. We have 2 solutions because it went through the x-axis twice. All right, for this one, we have an xy table. Our vertex is at -5, 0. All right, I'm going to plot these points. All right, so once we plot those points and we connect them to make a curve, you can see that we actually just touch the x-axis right there. We don't actually go through it. So this is called a double root. Okay, so this one solution is what we refer to as a double root, meaning it's the same answer twice. Since it's the same answer twice, we only have to write it one time. So x equals -5. All right, and then this last one down here, again, XY table. So my vertex is at 3, -1. And we have 3 and 0, 0 and 3. All right, and then once we plot the points, then we connect them using a smooth curve. And you can see again, we cross twice, right? And again, you can see that in the table right there, we cross twice. So my two solutions are x equals 2 and x equals 4. Okay, so that's just basically from graphs. You're looking where it crosses the x-axis, and that's your solution or solutions. More than likely it's 2. Okay, so that's really easy. We're not going to spend a lot of time on that portion of it. So we're going to look at a second way to solve quadratic equations, and that's through factoring. Okay, now factoring is going to go back and it's doing the opposite of what we did the other week with FOIL. So with FOIL, we multiplied, right? So if I go ahead and I multiply this out, or I FOIL this, 2x squared plus 6x minus 4x minus 12. We have the two terms in the middle. So plus 2x minus 12. So we end up with this, 2x squared plus 2x minus 12. Okay, so now what we're going to be doing is that we're doing the opposite of FOILing. So now I'm going to give this to you, and we're going to use factoring, which is like dividing, and we're going to get back to our two sets of parentheses. Okay, so we're doing the opposite of factoring. So starting with a quadratic equation and getting to where we have our two sets of parentheses. Okay, factors. So let's talk about just what the word factors means. So when we say we're factoring, we're finding the factors. Factor is just a number that divides the given number without a remainder. So for example, 5 is a factor of 15. 4 is a factor of 12 because 4 divides evenly into 12. 2 is a factor of 8 because 2 divides evenly into 8. 9 is a factor of 54 because 9 divides evenly into 54. So this is where knowing your multiplication tables is very, very beneficial. So I'm going to show you how I want you to go through. When we're doing factors, we're going to have to find factors of all different numbers. And I'm going to show you how I want you guys to list out factors as we go through. So if my number was 36 and I had to find all the factors of 36, we always start with 1 times the number that we have. So 1 times 36. And we go in order. So now we do 2. 2 times 18. Then we do 3. Now, to see if a number is divisible by 3, you take your digits and add them together. So 3 plus 6 gives me 9. Does 3 divide evenly into 9? Yes, it does. So therefore, 3 divides evenly into 36. So you can do that with any number, and that also works with 9s as well. If the sum of the digits is divisible by 9, then the whole number is divisible by 9. All right, so we have 3 times 12, 4 times 9, 5 doesn't go into it, 6 times 6. Now, notice I have the same number twice. If you get to where you have the same number twice, you know you have all of the factors. All right, if we looked at 60, we do 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. 11 doesn't go into it. I'm sorry, 7 doesn't go into it. 8 doesn't go in evenly to 60. 9 doesn't go in evenly to 60. 10, but 10's already on my list. So once you get to a number that's already on your list, then you know you have all of the factors. So what I want you to do is I want you to pause the video right now, and I want you to go ahead and find the factors of 42 and 120. And then after you have that, then replay the video and see if you are correct. So right now, go ahead, pause the video. All right, so hopefully you got all your factors. So again, with this, you're gonna need to know your factors of different numbers. Okay, so again, we just talked about FOIL is multiplying, so now factoring is gonna be dividing. Factors are numbers that divide evenly into the number that you want without a remainder. Here, this is how we list our factors. Okay, so then going into this, so we need to talk about signs, positive and negative, okay? So remember with FOIL, right, our last letter is going to be the L for last. So that means we take the last times the last. This is where signs matter, right? So if I have this times this, if it's a positive times a positive, then our last number in FOIL, like our last answer, like this number right here, or this number right here, our last number, is going to be positive. If I do a negative times a negative, I get a positive. Positive times a negative is negative, and negative times a positive is negative. All right, so let's think about this. If I had -2 times what gives me -6? Well, I already have one of them negative, so the other one has to be positive. 4 times what gives me 24, and that would be 6. Positive times a positive gives me positive. Negative times what gives me a positive? This has got to be a negative, so it's -2. 9 times what gives me a -27? That's going to be -3. So notice you are not only having to find the number, but also the sign. So our general rule here is if you have the same signs, and this is when multiplying, right? That equals a positive answer. So positive times positive is positive, negative times negative is positive. So, right, so if we have the same signs, our answer is positive. Different signs mean negative. Okay, again, we're talking about multiplying. So if we have different signs and we multiply them together, then we get negative. Sorry, that's my cat. All right, so you can see here, negative times a positive gives us a negative, okay? So this is really important to understand when it comes to factoring. All right, go ahead and flip it over to the next page. All right, now this looks really scary. It looks like a lot of steps, but it's not bad, I promise. It's just really hard to write this out in steps. You'll see over here the work is hardly anything at all, okay? All right, so we are going to factor x squared minus 15x plus 54. So today we're just going to talk about factoring, and then tomorrow we'll talk about taking once we factored it and then solving the equation. So we're going to do this in 2 parts. All right, so if we start with x squared minus 15x plus 54, this is telling us what we do, and we're going to show it over here using this example. Okay, so I'm going to open up 2 sets of parentheses. Because I'm using the letter x in my equation, I'm going to start each one with x. We multiply our a times our c. So let's go back. Let's remember standard form, right? So a is here, c is here. So you're going to multiply. Now, you don't see an a here, but what number is really there? 1. So we're going to take 1 times 54 gives me 54. Okay? So we multiplied a times c. Find all of the factors of this product. So this is where we're finding factors of 54. So I'm going to write 54. I'm going to go through 1 times 54, 2 times 27, 3. So 5 plus 4 gives me 9. 3 can divide evenly to 9, so therefore 54 is divided by 3. So that's going to be 18. 4 doesn't go into it. 5 doesn't. 6 doesn't. 6 does, sorry. 6 times 9. Jeez Louise. Okay, so we have our factors. 1 times 54, 2 times 27, 3 times 18, and 6 times 9. All right, step 4. Look at the second operation in the quadratic equation. So it gives us an example. So we're looking at this sign right here. Find the pair of factors that adds or subtracts, depending on what the second sign operation is, to get the middle number. So since this is a plus here, I'm finding factors of 54 that add to give me 15. Okay, again, it's add because this sign right here is a plus. Now, if that were a minus, we would want factors of 54 that subtract to give us 15. All right, so add to give us 15. So if I look at my list, what two pairs of numbers add, or what pair of numbers adds to give me 15? It's going to be 6 and 9. Put the larger factor in the first set of parentheses and the smaller factor in the second set of parentheses. So 9 and 6. Now, step 7, it says if a equals 1, then you can skip this step. So for today, you guys are going to be skipping step number 7 because our a is always going to be 1. All right, again, a is referring to the number in front of the x squared. Step 8, bring down the first operation. So this first operation, I'm going to bring it straight down into the first set of parentheses. Looking at the second operation, determine based on the first operation what it should be. Okay, so remember in FOIL, I'm going to take -9 times some type of 6 to get a positive 54. So if this one is negative, that means this one's going to have to be what so that it turns out to be positive? This one's going to be negative. Okay, another way to look at it is if your second sign is plus, these signs match. If your second sign is minus, these signs will be opposites. Okay, and that's it. So our answer is x minus 9, x minus 6, and that's it. So we factored it. So we went from where this was this was here, and we divided it out and we turned it into 2 sets of parentheses. Now, if I were to FOIL this, right, x times x is x squared minus 6x minus 9x and then plus 54, right? This would become exactly what I started with, right? So these two match, and if they don't match, then you know you did something wrong. So this is just our check. This is just a check, right? A lot of times what I do is I just multiply the first two, x squared, and then the last two, and pretty much if that works out, then the middle ones probably are going to work out as well. Okay, you don't have to do this every single time, but it would probably be really smart to do it. All right, that was a lot to take in. So let's do a couple problems together and then you'll work on some. Again, other variations of this factoring is when you have to factor out a GCF or when your a value is greater than 1. And we'll get to that later, probably after Christmas. All right, so step 1, open up 2 sets of parentheses. We're using x, so I'm going to put x first in each one. I'm going to take a times c. 1 times 4 gives me 4. So I'm looking for factors of 4 that subtract because this second sign is a minus to give me 3. Now, I don't care about that sign. I just care about the number, okay? I don't care about the sign. So factors of 4 that subtract to give me 3. So that's going to be 1 and 4. It tells us up here, number 6. Put the larger factor in the first set of parentheses, so 4 goes first, and then 1. The first sign comes straight down. The second sign is a minus, which means the only way to FOIL and get the last one, so I have -4 times what type of 1 gives me a -4. So that's going to have to be a positive 1, because a negative times a positive is going to give me a negative. Again, another way to look at it is if your second sign is minus, these signs have to be opposites. Okay? And that's it. There's your solution. Again, real quick, x times x gives me x squared. -4 times 1 gives me -4. Just as a double check. All right, number 2. Open up 2 sets of parentheses. I'm using the letter B this time because that's what's in the problem. So take a times c. So 1 times 8 gives me 8. So I'm looking for factors of 8 that are going to add, because this is a plus sign, to give me 6. A times C gives me 8. Factors of 8 that add to give me 6. And that's 2 and 4. Put the bigger number first. Bring down the first sign. The second sign is plus. So if I have a -4 times a what type of 2 is going to give me a +8. And that's going to have to be negative. Again, you can look at that second sign and it's a plus. So these signs have to match. Okay? And there's my answer. Again, I can double check. B times B is B squared. -4 times -2 gives me a +8. All right, number 3. Open up 2 sets of parentheses. Put x first in each one. 1 times 8 gives me 8. Factors of 8 that are going to subtract to give me 7. Again, I'm looking at this second sign to be able to determine what I'm doing with my factors. So it's 1 and 8. Bigger number goes first. First sign goes straight down. Second sign is a minus, which means these have to be opposites. So this has to be plus. You can also think of this as -8 times what type of 1 gives me a -8, and that has to be a +1. Number 4, open up 2 sets of parentheses. N goes first in each one. 1 times 30 is 30. So I'm looking for factors of 30. Okay, factors of 30 that subtract to give me, well, there's just an N here. So really, what is that? That's just a 1, right? So I need factors that are going to subtract to give me 1. So factors that subtract to give me 1 is going to be 6 and 5. First sign comes straight down. Now I have a -6 times a what type of 5 to give me a -30. So this is going to have to be positive. Again, you can look at this is a negative right here, a minus sign. So these have to be opposites. Okay, so again, if your last sign, so if we have ax squared plus bx plus c, if this is a plus, then your signs in your parentheses have to match. All right, if this is a minus, then your signs in your parentheses have to be opposites. Okay? All right, if we look at number 5, n goes first. 1 times 12 gives me 12. I'm looking for factors of 12 that are going to add to give me 7, and that's 3 and 4. Bigger number always goes first. First sign goes straight down. Second sign is a plus. We said if the second sign is a plus, the signs in the parentheses have to match. So if this is a plus, then this has to be a plus. Number 6, open up 2 sets of parentheses. V goes first in each set. I'm looking for factors of 48. 1 times 48. Factors of 48 that subtract to give me 2. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So they have to subtract to give me 2. That's going to be 6 and 8. Which one goes first, 6 or 8? Yep, 8 does, because it's bigger. First sign comes straight down. Second sign is a minus, so if the second sign is a minus, they have to be opposite. So if this is minus, this has to be opposite, so that has to be positive. Okay? All right, what I would like for you guys to do right now is I would like for you guys to try the problems that are over here on this page. Okay? So you're going to work on numbers 1 through 12. Okay? For number 10, so you can look at it like this. That might make a little bit more sense to you. I'm putting the 0x in the middle because it's missing, so the b value is missing. So I plug in a plus 0x just to make it easier. Do the same thing. Factors of 36 that subtract to give you 0, so it's going to work, okay? All right, if you have questions, send Miss Carlock a Schoology message or come see me, but we'll go over all of this tomorrow in class. All right, guys, thanks.